Picture a photograph you have probably seen. March 2016. A man climbs out of a Soyuz capsule somewhere in the frozen steppes of Kazakhstan, and the Russian recovery crews are already moving toward him across the snow. He has been in space for 340 days. His body has forgotten what weight feels like. His spine has stretched by nearly 2 inches in the absence of gravity, and his muscles have atrophied despite thousands of hours on a treadmill bolted to the wall of a tin can moving at 17,000 miles an hour. He looks tired in the way that only astronauts look tired, not sleepy, but fundamentally recalibrated, as though some internal gyroscope is still spinning in the wrong direction. His name is Scott Kelly. He is an American astronaut, a retired Navy captain, and by most reasonable definitions, a hero. The cameras capture his first moments back on Earth. The recovery teams help him into a chair because he cannot yet stand. Someone hands him a satellite phone so he can call his family. And somewhere in Texas, a man who looks almost exactly like him, his identical twin brother Mark, also a former astronaut, is watching the live feed and doing a calculation in his head that very few human beings have ever had reason to do. He is figuring out how much older he just became. The answer, when NASA later confirmed it, was 5 milliseconds. 5 1,000ths of a second. In the time it takes a housefly's wing to beat once, Mark Kelly aged that much more than his brother. Not because Scott was further from Earth, not because of cosmic rays or the stress of isolation or any of the other biological tolls that spaceflight extracts, but because time itself moved differently for him. Slower, more gently. The universe handed Scott Kelly a tiny, measurable discount on aging, and it did so for one reason. He was moving fast, and he was far from the pull of heavy things. Mark joked about it afterward. He said, "Where I used to be just 6 minutes older, now I am 6 minutes and 5 milliseconds older." It was the kind of joke only a physicist or an astronaut could make. Dry, understated, built on the quiet understanding that something profound had happened, and that the only sane response was to laugh at it, because the alternative was to sit with what it actually meant. And what it actually means is this: the man who came back from space was not the same man who left. Not in some metaphorical sense about how travel changes you, or how solitude reshapes the soul, in the most literal sense available to physics. His personal timeline had diverged from everyone else's on the planet. His clocks, the clocks inside his cells, the decay rates of the atoms in his bones, the rhythms of his heartbeat and his thoughts and his breathing, had all been running at a slightly different pace than his brother's, than yours, than mine. For 340 days, Scott Kelly had been drifting out of sync with the present, and when he landed, he was 5 milliseconds behind. Or, depending on how you think about it, 5 milliseconds ahead. Now let me be clear about something. 5 milliseconds is not a meaningful amount of time by any human standard. You cannot perceive 5 milliseconds. You cannot spend them or save them. If someone stole 5 milliseconds from your life, you would not notice. Your nervous system takes longer than that to register the feeling of a pinprick. The light from a muzzle flash takes longer than that to reach your eye. In the space of 5 milliseconds, sound travels less than 6 feet. It is, by any reasonable measure, nothing. But here is where the story stops being about Scott Kelly and starts being about you. About everyone. About what happens when humanity looks up at the stars and decides, seriously, to go. Because the 5 milliseconds are not the point. The 5 milliseconds are the proof. They prove that the rule applies. Not to particles in an accelerator. Not to clocks on satellites. Not to abstract mathematical constructs designed to make undergraduates weep. To people. To bodies. To the lived experience of being a conscious creature moving through the universe. Relativity does not care whether you're a cesium atom or a Navy captain with a brother in Texas. It applies to you in exactly the same way. And the implications of that fact scale with ambition in ways that will reshape what it means to have a home. Tonight, we are going to follow that scaling. We are going to trace what happens when the 5 milliseconds become 5 years, then 50, then 500. We are going to travel alongside hypothetical ships to nearby stars and watch what happens to the people they leave behind. We are going to sit with the mathematics of a phenomenon so counterintuitive that even Einstein called it the most surprising consequence of his own theory. And by the end, we will have to ask ourselves, what does it mean to go home if home is not a place but a moment in time, and the moment is gone? If these slow journeys help you drift off or stay curious through a long night, a like and a subscribe are always appreciated. Consider it a small gift to the algorithm that brought you here. Now let us begin. The man who made all of this possible died in 1955, which means he never saw a human being orbit the Earth. He never watched Neil Armstrong's boot touch lunar dust. He never saw the International Space Station rise piece by piece into the sky, or the Hubble images of galaxies so distant their light left before the Earth had life. But he predicted, with a confidence that still astonishes, what time would do to anyone who tried to reach those places. His name, of course, was Albert Einstein. And in 1905, working as a patent clerk in Bern, Switzerland, he published a paper that broke time. The paper was called On the Electrodynamics of Moving Bodies, and it contained, among other things, a simple thought experiment. Imagine, Einstein said, two observers. One is standing still, the other is moving past at a constant velocity. Not accelerating, not decelerating, just cruising by at some fraction of the speed of light. Now imagine that each observer has a clock. What Einstein showed, mathematically, rigorously, undeniably, was that the moving observer's clock would tick slower. Not because the clock was broken, not because of some mechanical flaw or perceptual trick, because time itself for that moving observer was passing more slowly. This is called time dilation, and the word dilation is important. It suggests stretching, widening. The minutes grow longer, the seconds expand. If you're moving fast enough, a single heartbeat in your frame of reference might correspond to 2 heartbeats, or 10, or 1,000 in the frame of someone standing still. Your experience of duration, the fundamental medium in which consciousness exists, becomes disconnected from everyone else's. Stop and feel the weight of that for a moment. This is not a metaphor. It is not a quirk of measurement or a limitation of human perception. It is a structural feature of the universe. Time is not a river flowing at a constant rate for all observers. Time is a landscape with topography, and your path through that landscape determines how much of it you experience. Move faster, and the landscape compresses. Move slower, and it stretches. The universe does not care what your intuition says time should be. It only cares about the geometry of space-time, and the geometry says motion costs time. Einstein published this in 1905. It took decades for the experimental confirmation to catch up, but catch up it did. In 1971, 2 physicists named Joseph Hafeel and Richard Keating put cesium atomic clocks on commercial airliners and flew them around the world, once eastward, once westward. When the clocks returned, they had drifted out of sync with identical clocks that had stayed on the ground. The differences were tiny, nanoseconds, but they were exactly what Einstein's equations predicted down to the margin of error. The clocks that moved had experienced less time, and then there is the other flavour. Because velocity is not the only thing that warps time, gravity does it too. Einstein figured this out in 1915, a decade after special relativity, when he published his general theory. The idea is harder to summarise, but it comes down to this. Mass curves space-time. The heavier the object, the deeper the curve, and the deeper the curve, the slower time passes at the bottom of it. Think of Earth as sitting in a kind of gravitational dimple. Everything on the surface is at the bottom of that dimple, and time there runs slower than it would further away. If you climb a mountain, you age faster than someone at sea level. If you fly in an airplane, your clocks tick slightly faster than clocks on the ground, at least until your velocity kicks in and starts slowing them down again. The two effects compete. They push in opposite directions. Velocity slows your clock, altitude speeds it up, and the balance between them determines how your personal time compares to anyone else's. This is what happens to astronauts. On the International Space Station, crew members are moving at about 17,500 miles per hour, fast enough that the velocity effect dominates. Their clocks slow down, they age less, but they are also further from Earth's centre, where gravity is weaker, and that effect tries to speed their clocks up. On the ISS, the math works out so that the velocity effect wins. Net result, astronauts come home younger than they would have been if they'd stayed. Not by much, not by enough to matter in any practical sense, but by enough to measure, by enough to prove. Scott Kelly's 5 milliseconds were not handed to him by a cosmic lottery. They were calculated from the geometry of his path through space-time, the velocity he travelled, the altitude he maintained, the 340 days he spent in a frame of reference slightly offset from everyone on the surface of the planet. When you add it all up, you get exactly what the Kelly brothers observed, a tiny, irreversible drift in their personal ages. Now multiply that drift by a longer mission, multiply it by a faster ship, multiply it by the ambition that humanity has always had to reach further, to go faster, to push into the dark, and watch what happens. The current record holder for human time travel is not Scott Kelly. Kelly's 340 days aboard the ISS were impressive, but they have been exceeded. Many times, in fact, by Russian cosmonauts who accumulated their time across multiple missions. The title belongs to a man named Sergei Krikalev, a Soviet and later Russian cosmonaut who logged more than 803 days in orbit over the course of 6 separate space flights. Krikalev's career spanned some of the most turbulent years in spaceflight history. He was aboard the Mir space station in 1991 when the Soviet Union collapsed beneath him, literally, politically, while he floated overhead. He watched his country dissolve from orbit and came home to a nation that no longer existed. He later flew on both American space shuttles and Russian Soyuz missions, became a veteran of the early ISS expeditions, and retired in 2007 with more cumulative time in space than any human being who had ever lived. The math on Krikalev is straightforward but strange. At orbital velocity, each day in space earns you roughly 0.0025 milliseconds of time dilation relative to someone on Earth's surface. Over 803 days, that adds up to about 20 milliseconds, 20 thousandths of a second, the span of a single wing beat from a hummingbird. And yet that number makes Sergei Krikalev, in the most literal sense physics allows, the most time-travelled human being in history. Let that phrase settle for a moment. Time-travelled. We use those words casually, as if they belong to science fiction, as if they describe something that happens in stories but not in laboratories. But Krikalev travelled through time, forward, by 20 milliseconds. The Earth's clocks advanced by 803 days, while his clocks advanced by 803 days minus 20 milliseconds. He returned to a planet that had experienced slightly more time than he had. He is younger than he should be, not by much, but by some. And this is where the quiet cost begins to emerge. Because there is no going back. Krikalev cannot undo those 20 milliseconds. He cannot reclaim them. They are not sitting in an account somewhere, waiting to be withdrawn. They are gone. Or rather, they never happened to him in the first place. The universe gave him a tiny discount on the price of existence, and the discount is permanent. Every person he meets, every friend and family member and stranger on the street, has experienced 20 milliseconds more of reality than he has. The gap is microscopic, it is meaningless in practice, but it is real, and it scales. Consider the moon. The Apollo astronauts who walked on its surface in the late 1960s and early 1970s were further from Earth than anyone had ever been. The round trip took about 8 days. The velocity was lower than orbital speed, about 25,000 miles per hour at translunar injection, and the gravitational environment was different. The math is more complicated, but the net effect was still measurable. Each Apollo astronaut came home fractionally younger than they would have been. The numbers were in the microseconds. The principle was the same. Now consider Mars. A crewed mission to Mars, using current technology, would take somewhere between 6 and 9 months each way, with perhaps a year spent on the surface waiting for the optimal return window. Call it 2.5 years total. At interplanetary cruise velocity, tens of thousands of miles per hour but nowhere near light speed, the time dilation would still be modest, maybe a few dozen milliseconds. The crew would return to an Earth that had aged a few dozen milliseconds more than they had. The difference would vanish into the noise of daily life. No one would feel it. But Mars is close. Mars is practically next door. It orbits the same star we do, at distances measured in mere light minutes. When humans start thinking seriously about interstellar travel, about reaching other stars, other solar systems, other worlds that might harbour life, the numbers change. They change dramatically. The nearest star to our Sun is Proxima Centauri, a dim red dwarf about 424 light-years away. A light-year is the distance light travels in 1 year, moving at 186,000 miles per second. That works out to about 5.88 trillion miles. Multiply by 4.24, and you get roughly 25 trillion miles. A distance so vast that human intuition cannot grasp it, only gesture toward it. At the speed of the Voyager 1 probe, the fastest object humanity has ever launched, moving at about 38,000 miles per hour. The journey to Proxima Centauri would take over 73,000 years. No human mission will ever travel at that speed for that duration. It is not a realistic scenario, but it illustrates the scale of the problem. Now imagine something faster. Imagine a ship that could accelerate to a meaningful fraction of the speed of light, say 10%. At 0.1 c, Proxima Centauri is about 42 years away. Still a multi-generational voyage, still beyond the lifespan of a single crew. But the time dilation effects would become significant. At 0.1 c, clocks on the ship would run about 0.5% slower than clocks on Earth. Over 42 years, that's a difference of several months. The crew would return, assuming they could somehow turn around and come back, to an Earth that had aged years more than they had. But 10% of light speed is still slow by relativistic standards. Push the ship faster. Push it to 0.5 c, or half the speed of light. At 0.5 c, the time dilation factor is about 1.15. For every year that passes on the ship, 1.15 years pass on Earth. The journey to Proxima Centauri from the ship's perspective takes about 7.5 years. But on Earth, about 8.6 years pass. The crew comes home to find themselves a year younger, relative to everyone they left behind. A year. Not milliseconds, a year. Push faster still. At 0.9 c, 90% of light speed, the time dilation factor jumps to about 2.3. The ship's clock ticks less than half as fast as Earth's. The journey to Proxima Centauri, from the ship's perspective, takes only about 2 years, but on Earth, 4.7 years have passed. The crew returns nearly 3 years younger than their age would suggest if they'd stayed home, and here is where the mathematics become almost unbearable. At 0.99 c, 99% of light speed, the time dilation factor is 7.09. The ship's crew experiences the journey to Proxima Centauri as a voyage of about 7 months. 7 months of their lives. But on Earth, 4.3 years pass. The crew returns to find that while they have aged less than a year, everyone they know has aged more than 4 years. Children have started school, friends have moved away, parents have grown old. At 0.999 c, the factor is 22.4. The journey takes weeks from the crew's perspective, years from Earth's. At 0.99 c, the factor is 70.7. The journey feels like days. On Earth, decades have passed. And at 0.9, a velocity so extreme that our current technology cannot even dream of it, the factor is 223.6. A round trip to Proxima Centauri would feel like hours to the crew, but when they returned to Earth, they would find that an entire human lifetime had elapsed in their absence. Their parents would be dead. Their children would be elderly. The world they left would exist only in history books. Stop and feel the weight of that. This is not speculation about possible physics. This is not a hypothesis waiting to be tested. This is the straightforward, experimentally verified consequence of special relativity applied to velocities that humanity does not yet possess but has every reason to pursue. If we ever build ships that can reach meaningful fractions of light speed, and if we want to explore the galaxy, we will have to, then the people aboard those ships will be permanently separated from the timeline of Earth, not by walls or distances or communication delays, though those will exist too, by time itself. They will return to a future that does not remember them. The phrase that physicists use is time travel into the future. It sounds glamorous when you say it quickly. It sounds like a superpower, like something a hero might do. But consider what it actually means. It means that the present you leave closes behind you. It means that the people you love continue to age while you do not, or while you age more slowly, which is the same thing. It means that home stops being a place you can return to, and becomes a moment that recedes into the past at a rate you cannot control. And the cruelest part is that it only works in one direction. Relativity permits time travel into the future. It does not permit time travel into the past. There is no known physics that would allow the crew of a relativistic starship to return to the moment they left. The arrow of time points forward for everyone, everywhere. The difference is only how fast you move along it. Travel slowly, and you experience the full weight of every passing second. Travel fast, and the seconds compress, but they still pass. You still move forward. You just arrive at the future sooner than everyone else, and then you are stuck there. Imagine being one of those astronauts. Imagine climbing into a ship that can reach 0.99 c. waving goodbye to your family and knowing with mathematical certainty that by the time you return they will be gone, not dead necessarily. Maybe they will live long, healthy lives. Maybe medical technology will extend their lifespans far beyond what we consider normal today. But they will have lived those lives without you. They will have experienced decades while you experienced months. The person who comes home will be a stranger to the world, and the world will be strange to them. This is the quiet cost that relativity hands to every space traveller. It is written into the fabric of the universe, as fundamental as gravity, as inescapable as entropy. And it grows with every increment of velocity, every light year of distance, every ambition that reaches beyond the cradle of Earth. Astronauts today come back to a world that is only milliseconds out of step. The gap is invisible. The reunion photos look normal. The welcome ceremonies proceed without anyone stopping to note that the hero in the chair has been slightly detached from the stream of time that carries everyone else. We do not think of Scott Kelly as a time traveller. We think of him as a man who spent a year in space and then came home. But he is a time traveller, by 5 milliseconds. And the only thing separating 5 milliseconds from 5 years, or 50 years, or 5 centuries, is the speed of the ship and the length of the voyage. Humanity has not yet built ships that can reach relativistic velocities. We have not yet sent anyone beyond the moon. The nearest star remains impossibly distant by any technology we currently possess. But we are a species that has spent its entire existence pushing boundaries. We climbed out of trees, we crossed oceans, we flew, we split the atom, we walked on another world, and now we are building the tools that might someday carry us to the stars. When we do, not if, but when, the mathematics of relativity will be waiting for us. The first interstellar explorers will know, before they leave, what they are giving up. They will understand, in a way that no previous generation of explorers has ever had to understand, that their journey is a one-way trip through time. They can return to Earth. They cannot return to the Earth they left. The people they knew will have aged or died. The culture they loved will have transformed. The languages may have shifted. The technologies will be unrecognizable. They will step off their ship into a world that has moved on without them, and they will have to build new lives in a future they did not experience. This is not a tragedy exactly. Or it is not only a tragedy, there is something magnificent in it too, a kind of sacrifice that earlier generations could not even conceptualize. To leave not just your home but your time. To accept, with open eyes, that the clock of your life will fall out of sync with everyone you love. To do it anyway, because the stars are worth reaching, because the human need to explore is stronger than the human need for permanence. But it is also, undeniably, a cost, and we should name it clearly before we pay it. The reunion photographs will still happen. The welcome ceremonies will still proceed. The astronaut will still climb out of the capsule and squint at an unfamiliar sun and feel the weight of a planet they barely remember. But the smiles in those photographs will carry a different kind of grief. The hugs will reach across a gap measured not in miles but in years, and somewhere in the back of everyone's mind will be the knowledge that the person who came back is not quite the person who left. Not because space changed them, though it will have, because time itself treated them differently. And time once spent cannot be recovered. Time once lost cannot be found. The ledger of existence does not balance. It only accumulates second by second in directions that diverge more steeply the faster you move and the further you go. This is what Einstein discovered in a patent office in 1905. This is what Haffel and Keating proved with atomic clocks on airliners in 1971. This is what Scott Kelly demonstrated with his own body in 2016, and what Sergei Krikalev has lived more completely than any other human being. Time is not what we thought it was. It is not a universal background against which events play out. It is a dimension like any other, subject to the geometry of motion and mass, and that geometry has consequences. We are only beginning to understand what those consequences will demand from us. The geometry has consequences, and those consequences scale. Consider for a moment the distances involved. When we speak of interstellar travel, we are not speaking of the kind of distances that human beings have ever crossed. The moon is roughly 240,000 miles away. Apollo astronauts made that journey in about 3 days. Mars, at its closest approach, sits roughly 34 million miles from Earth, a voyage that would take, with current propulsion technology, somewhere between 6 and 9 months. These are enormous distances by any historical standard. They dwarf the voyages of Columbus, of Magellan, of every explorer who ever pushed into unknown waters. But they are, in cosmic terms, almost nothing. They are the distances between neighbours in the same apartment building. They are steps across a living room. The nearest star system to our Sun is Alpha Centauri, a triple star system consisting of Alpha Centauri A, Alpha Centauri B, and the small red dwarf Proxima Centauri. Proxima is the closest of the three, and it sits approximately 424 light-years away. Let that number settle for a moment. A light-year is the distance that light, the fastest thing in the universe, the cosmic speed limit itself, travels in 1 year. Light moves at roughly 186,000 miles per second. In 1 year it covers about 5.8 trillion miles. Multiply that by 4.24 and you get the distance to Proxima Centauri, roughly 25 trillion miles. 25 trillion miles. Try to picture that. If you drove a car at highway speeds 60 miles per hour, without stopping, it would take you about 47 million years to reach Proxima Centauri. If you flew on a commercial airliner at 600 miles per hour, it would take 4.7 million years. If you rode on the fastest spacecraft humanity has ever built, the Parker Solar Probe, which has reached speeds exceeding 430,000 miles per hour, it would still take roughly 6,600 years to arrive. 66 centuries. More than twice the span of recorded human history. And that is just to reach the nearest star. The galaxy contains somewhere between 100 billion and 400 billion stars, scattered across a disk roughly 100,000 light-years in diameter. The Milky Way is not a neighbourhood. It is not even a continent. It is an ocean so vast that the word vast loses all meaning. This is why interstellar travel, if it ever happens, will require ships that move at a significant fraction of the speed of light. Not because speed is glamorous, not because we are impatient, but because the alternative is voyages that last longer than civilizations, longer than species, longer than the geological epochs that reshape continents. At 1% the speed of light, already faster than anything we have ever built by a factor of hundreds. A trip to Proxima Centauri would take 424 years. At 10% the speed of light it would take 42 years. At 50% the speed of light it would take a little over 8 years. And here is where Einstein's equations become inescapable. At these velocities, time dilation is no longer a curiosity measured in milliseconds. It becomes a structural feature of the voyage. Let us walk through the mathematics slowly, because the numbers deserve to be felt, not just calculated. Time dilation depends on what physicists call the Lorentz factor, usually represented by the Greek letter gamma. The formula is elegant and ruthless. Gamma equals 1 divided by the square root of 1 minus velocity squared divided by the speed of light squared. At everyday speeds, walking, driving, flying, gamma is so close to 1 that the difference is effectively 0. At 10% the speed of light, gamma rises to about 1 to 5. At 50% the speed of light, gamma reaches approximately 1.15. At 90% the speed of light, gamma jumps to about 2.29. At 99% the speed of light, gamma soars to roughly 7.09. And at 99.9% the speed of light, gamma exceeds 22. What does gamma mean in practical terms? It is the ratio between the time experienced by a stationary observer and the time experienced by the traveller. A gamma of 2 means that for every year that passes on the ship, 2 years pass on Earth. A gamma of 7 means that for every year of shipboard time, 7 years slip by for everyone who stayed behind. A gamma of 22 means that a single year of the voyage consumes more than 2 decades of Earth time. Now imagine a journey. A ship departs Earth bound for Proxima Centauri 424 light-years away. The ship accelerates to 90% the speed of light, cruises for most of the trip, then decelerates for arrival. Accounting for the acceleration and deceleration phases, the ship time for such a voyage would be roughly 2.6 years. The crew would experience 2 years and 7 months of travel. They would age by that amount. Their hair would grow by that amount. Their hearts would beat through that many days and nights. But on Earth, the clocks would tell a different story. While the crew experienced 2.6 years, Earth would experience roughly 4.9 years. The travellers would return, if they returned immediately, which would double the elapsed times, to find that nearly a decade had passed on the planet they left. Friends who were in their 20s would now be in their 30s. Children would have graduated from school. Political administrations would have changed. Technologies would have advanced. The news cycle would have churned through thousands of stories the travellers never heard. That is the cost of a single round trip to the nearest star at 90% the speed of light. A decade of temporal displacement. 10 years of life that the travellers did not experience but that everyone else did. Now push the numbers further. Humanity's ambitions will not stop at Proxima Centauri. The galaxy beckons. Other star systems offer other possibilities. Planets that might harbour life. Resources that might sustain colonies. Mysteries that might reshape our understanding of the universe. The star Tau Ceti sits roughly 12 light-years from Earth. Epsilon Eridani sits about 10.5 light-years away. The TRAPPIST-1 system, with its tantalising collection of 7 Earth-sized planets, lies approximately 39 light-years distant. Kepler 442b, a potentially habitable world, orbits a star 112 light-years from us. Run the mathematics for a voyage to the TRAPPIST-1 system. At 90% the speed of light, the ship time for a one-way journey would be roughly 19 years. The crew would age through nearly 2 decades of travel. But on Earth, those same 19 ship years would correspond to roughly 43 years of elapsed time. A crew that departed as young adults in their 20s would arrive at TRAPPIST-1 in their 40s and would find, if they could somehow receive transmissions from home, that Earth had aged into a different era. Their parents would likely be dead. Their children, if they had left children behind, would now be older than the travellers themselves were when they departed. The cultural references they carried in their memories would be historical artefacts. The music they loved would be retro. The slang they spoke would be quaint. And that is just a one-way journey. A round trip would double the displacement. A crew that spent 38 ship years travelling to TRAPPIST-1 and back would return to an Earth that had experienced 86 years of history, nearly a century. The travellers would step off their ship into a world where almost no one they had known still lived, where the language had shifted in ways subtle and strange, where the political maps showed nations that did not exist when they left, and lacked nations that seemed eternal when they departed. They would be immigrants from the past, carrying memories of a world that had become, in the interim, a kind of fiction. This is not speculation about exotic physics or hypothetical technologies. This is a direct, unavoidable consequence of the universe's most thoroughly tested theory. Special relativity has been confirmed by every experiment ever devised to check it. The equations that govern time dilation have been verified to extraordinary precision. We stake our GPS systems on them. We stake our particle accelerators on them. We stake the integrity of every physics experiment conducted in the last century on them. And those equations say, with mathematical certainty, that fast travel and long distances produce temporal displacement. There is no way around it. There is no trick to be discovered, no loophole to be exploited. The universe is built this way. Some have suggested that wormholes or warp drives might circumvent the problem, that sufficiently advanced technology could find shortcuts through space-time that avoid the time dilation penalty. Perhaps. General relativity does permit mathematical solutions that describe such structures, but no one has ever observed a wormhole, no one has ever demonstrated a warp drive, and the energy requirements suggested by the mathematics, requiring exotic matter with negative energy density, demanding power sources beyond anything humanity has ever conceived, make these possibilities remote, to put it gently. For the foreseeable future, and perhaps forever, interstellar travel will be subject to the same relativistic constraints that govern everything else in the universe. You cannot cheat time. You can only spend it differently. And so the question becomes, what does this mean for the explorers who will eventually make these journeys? History offers some faint analogies, though none of them truly capture the strangeness of temporal displacement. Sailors in the age of exploration left their homes for voyages that lasted years. Many never returned. Those who did often found that the world had changed in their absence, that fashions had shifted, that rulers had died, that friends had moved on. But they had aged alongside the world. The time they spent at sea was the same time that passed on land. They returned as older versions of themselves to a world that had aged in parallel. Interstellar travellers will not have this symmetry. They will return younger than they should be. The world will have outpaced them. The asymmetry is not an accident or a side effect. It is the fundamental nature of the journey, To travel fast is to travel forward, and everyone you leave behind travels forward faster. Think about what this means for families. A crew departs on a mission to a distant star system. Among them is an astronaut who leaves behind a spouse and a young child. The mission plan calls for a journey of 20 ship years, 10 years out, 10 years back. The astronaut kisses their child goodbye. The child is 5 years old. The astronaut promises to return. 20 years of ship time pass. The astronaut ages from 35 to 55. They have lived through 2 decades of exercise routines and research projects, and the strange camaraderie of a ship bound for the unknown. They have watched unfamiliar constellations wheel past the viewports. They have tasted synthetic food and recycled water, and the particular silence of deep space. And then, finally, they come home. But on Earth, the clocks have run differently. Let us say the ship travelled at 90% the speed of light. The Lorentz factor tells us that for every year on the ship, roughly 2.29 years passed on Earth. 20 ship years become approximately 46 Earth years. The astronaut, now 55, steps off the ship and looks for their family. The spouse, who was 30 when the astronaut left, is now 76. The child, who was 5, is now 51. The astronaut is younger than their own child. The spouse has lived an entire additional lifetime, 46 years of experiences, relationships, challenges, and transformations that the astronaut did not witness. The family reunion, if it can be called that, is a meeting of strangers. The astronaut remembers a 5-year-old's laugh, a young spouse's face. They find, instead, elderly people who carry those memories, but have long since grown beyond them. This is not tragedy in the traditional sense. No one has done anything wrong. The universe simply works this way, but it is a cost, and the cost is paid in the currency of human connection. Every relationship formed before the voyage becomes, in some sense, a relationship with the past. The travellers carry forward moments and memories that no longer correspond to the present. They become time capsules, relics of an era that everyone else has outgrown. And consider the psychological weight of knowing this in advance. The first interstellar explorers will not stumble into temporal displacement unaware. They will understand with perfect clarity what the journey will cost them. Before they board their ship, they will have to say goodbye to everyone they love, not in the way that sailors once said goodbye, hoping to return, but in the way that someone might say goodbye before dying. Because by the time they return, everyone they know will be gone. Not dead, necessarily, though many will be, but gone in the sense that the relationships will have transformed beyond recognition. The people will still exist, but the connections will not survive the temporal gap. What kind of person accepts that cost? What kind of psychology can embrace such a farewell? These are not technical questions, they are human questions, and they will define the character of interstellar exploration in ways that we are only beginning to imagine. The missions themselves will require new kinds of social structures. A crew bound for a star system 40 light-years away will not be a temporary team assembled for a specific task. They will be a permanent community, a society in miniature, designed to sustain itself across decades of travel. They will need to manage conflicts that span years. They will need to raise children born in transit, children who have never seen Earth and will arrive at their destination already middle-aged by ship time. They will need to preserve knowledge and skills across generations. They will need to maintain psychological health in the face of isolation so profound that it makes Antarctic research stations look like crowded city squares. And when they arrive, whether at a habitable world or a hostile one, they will carry with them a connection to Earth that is already decades out of date. Messages from home, travelling at the speed of light, will take years to arrive. News of births and deaths, of discoveries and disasters, will reach them long after the events have concluded. They will live in a perpetual temporal lag, receiving transmissions from a past that has already become history. Some theorists have suggested that this lag might eventually sever the connection entirely. A colony 40 light-years from Earth would experience an 80-year round-trip communication delay. A message sent in 2100 would not receive a reply until 2180. The people who sent the message would be dead before the response arrived. The conversations that bind societies together, the negotiations, the cultural exchanges, the shared understandings, would become impossible at these timescales. The colony would, by necessity, become its own civilization, developing its own customs and values and priorities, increasingly disconnected from the distant world that once sent it. This is the cosmic loneliness that Einstein's equations guarantee. Space is not just big, It is separated by time. Every light year of distance represents not just a physical gap, but a temporal one. The further you travel, the more you fall out of sync with where you came from. The universe, for all its vastness, is built on a geometry that makes communication difficult and synchronization impossible. And yet humans have always been willing to pay extraordinary costs for the privilege of exploring the unknown. The first people who left Africa walked into landscapes they could not imagine, facing predators and climates and distances that must have seemed insurmountable. They did it anyway. The first sailors who pushed beyond the sight of land risked everything on the possibility of finding something worth the risk. They did it anyway. The first astronauts who climbed into rockets understood that they were strapping themselves to controlled explosions, that the margin between survival and death was measured in fractions of seconds. They did it anyway. Perhaps the first interstellar explorers will carry the same spirit. Perhaps they will look at the equations, understand the costs, and decide that the stars are worth the price. Perhaps they will accept the farewell as a kind of gift, a chance to witness something that no one else will see, to stand on a world orbiting another sun, to know with absolute certainty that they have pushed the boundary of human experience further than anyone before them. But we should not romanticize the cost. We should not pretend that the sacrifice is trivial, or that the right kind of spirit can make the loss disappear. The explorers will lose things that cannot be recovered. They will age out of their own timeline. They will become, in a real and measurable sense, strangers to their own species, pioneers of a future that will have moved on without them, carrying only their own memories of a past that fades with every light year crossed. This is the weight that relativity places on ambition. This is the price that the universe charges for distance. And as humanity begins to contemplate voyages that extend beyond the solar system, this is the conversation we must begin to have. Not whether the physics allows it, the physics is settled, but whether we, as a species, are prepared to accept what the physics demands. The milliseconds have already begun to accumulate. Scott Kelly's 5 milliseconds, Sergei Krikolev's 20 milliseconds. Every astronaut who has ever orbited the Earth has fallen by some tiny fraction out of sync with the rest of humanity. The offsets are invisible. They are buried in the noise of daily life. No one notices. No one feels the weight. But the principle has been established. The precedent has been set. Time dilation is not a theoretical curiosity. It is an operational fact. And the further we push into space, the larger those fractions will become. Milliseconds will become seconds. Seconds will become minutes. Minutes will become hours, and hours will become days, and days will become years, and eventually, inevitably, if we are bold enough to keep reaching, years will become lifetimes. The clock is already ticking differently for some of us, and the divergence is only beginning. Now let us consider what this means for the human beings who will carry this weight, not the physics, which is settled, not the engineering, which is merely difficult, but the psychology, the interior landscape of a person who knows, with mathematical certainty, that they are aging out of their own timeline, that every second of their subjective experience corresponds to many seconds passing on the world they left behind, that the people they love are growing older faster than they are, that the institutions they trusted are transforming in ways they cannot witness, that the language they speak is drifting towards something they will not recognize. We do not have data on this. We cannot have data on this. No human being has yet experienced time dilation at a scale that registers psychologically. Scott Kelly came home 5 milliseconds younger than his brother, but he did not feel those 5 milliseconds. Sergei Krikalev accumulated 20 milliseconds of temporal offset across his career, but his mind processed no difference. The effect was real but invisible, measurable but not experiential, but scale it up, push the duration longer, push the velocity higher. At some threshold, and we do not know exactly where that threshold lies, the offset will cross from the abstract into the felt. A traveller will return and discover that their siblings have aged noticeably more than they have, that their parents have died of old age while the traveller was still young, that their children have become older than they are, that their grandchildren were born, lived and died in what felt like a decade. What does that do to a person? We have psychological frameworks for grief. We understand, at least imperfectly, how humans process the death of loved ones. We have studied trauma, resilience, meaning-making, the long, slow work of rebuilding a sense of purpose after profound loss. But we do not have a framework for this. for watching the people you love age past you, for returning to a world that has forgotten you, for carrying memories of a past that has become ancient history to everyone except you. The closest analogy we have is Rip Van Winkle. Washington Irving's character falls asleep in the Catskill Mountains and wakes 20 years later to discover that his wife has died, his friends have scattered, his village has transformed, and the political system he understood has been replaced by something entirely new. He is disoriented, he is confused, he is, in a profound sense, homeless. Not because he has no place to live, but because he has no place in time. Irving wrote that story in 1819 as a fable, a meditation on change and memory and the strange sensation of returning to a place that no longer feels like home. He could not have known that Einstein would provide the physics, less than a century later, to make such a story literally possible. That time dilation would transform Rip Van Winkle from a fairy tale into a prediction. The psychological literature on displacement is extensive but inadequate to this task. Refugees who have been forced from their homes experience profound dislocation. Soldiers who return from long deployments often struggle to reconnect with families and communities that have continued without them. Prisoners who serve decades find themselves released into a world that has moved on, where the cultural references have shifted and the technology has advanced, and the people they knew have aged or died or simply disappeared. These experiences are devastating. They reshape identities. They break people in ways that sometimes cannot be mended. But none of them involve watching your own children grow old while you remain young. None of them involve the specific vertiginous knowledge that the separation was not caused by circumstance or injustice, but by the fundamental structure of space-time itself. None of them involve returning to Earth and realizing that you are, in the most literal possible sense, from the past. This is the psychological frontier that awaits us. Not just the engineering challenge of building ships that can approach the speed of light. Not just the biological challenge of keeping human bodies alive for decades in the void. But the psychological challenge of preparing human minds for an experience that has no precedent in the entire history of our species. Consider the specific shape of the loss. You leave Earth at age 35. Your daughter is 5 years old. You travel to a star 12 light years away at 90% the speed of light. By your clock, the round trip takes roughly 11 years. You return at age 46 physiologically, psychologically, experientially. You have memories of the journey. You have witnessed alien sunsets, perhaps. You have done work that matters. You're tired, but proud. You're ready to come home. But on Earth, nearly 27 years have passed. Your daughter is 32. She has lived an entire adulthood without you. She has graduated from schools you never saw, formed relationships you never witnessed, perhaps had children of her own. She has grieved your absence, processed it, moved on. She has built a life that does not include you, because it could not include you, because you were 11 light years away experiencing time at a different rate. When you step off the ship, you're younger than your own daughter. Let that settle for a moment. Younger than your own daughter. The child you held as an infant, whose first steps you watched, whose scraped knees you bandaged. She is now older than you. She has grey in her hair while yours is still dark. She has wrinkles you do not have. She has arthritis, perhaps, or bifocals, or grandchildren of her own. And you are standing there, physiologically 46, looking at a woman in her 30s who is your child. What do you say to each other? What possible framework do you use for that conversation? She has had nearly 3 decades to imagine this moment, to prepare for it, to rehearse what she might say. You have had 11 years, but 11 years that felt complete, that had their own rhythm and purpose, that were not spent in anticipation of this reunion, but in the work of the voyage itself. You remember her at 5. She remembers you at 35. But neither of you is that person anymore. Both of you have changed, grown, become different. And the versions that meet on the landing pad are strangers in every way except blood and memory. This is not a problem that psychology can solve. This is not a challenge that proper preparation can eliminate. This is the cost, the unavoidable, non-negotiable cost that the universe charges for the privilege of travelling between stars. And here is the part that makes it harder. You chose this. You were not drafted. You were not exiled. You looked at the equations, understood the price, and decided that the mission was worth more than watching your daughter grow up. You made a calculation, conscious or unconscious, acknowledged or suppressed, that exploration mattered more than presence, That discovery justified absence, that the stars were worth your family. How do you live with that? How do you reconcile the version of yourself that made the choice with the version that must now face its consequences? The literature on regret, on moral injury, on the long psychological cost of impossible decisions. None of it is adequate to this scale. None of it has been tested against a choice this permanent, this irreversible, this cosmically enforced, because you cannot go back. That is the cruelest part. In ordinary regret, there is always the possibility, however theoretical, of making amends, of apologizing, of rebuilding, of somehow recovering what was lost. But time dilation permits no recovery. The 27 years your daughter lived without you are gone. They happened. They cannot be unlived. No return voyage, no reconciliation, no amount of presence now can give her back the father who was there for her childhood. That father does not exist. That father was traded for the stars. Now multiply this by a crew, a ship carrying 100 people, 1,000 people, each of them with families left behind, each of them with relationships that will be stretched across decades, each of them carrying the weight of a choice that will outlast any other choice they have ever made. The conversations on that ship, in the quiet hours, in the dark spaces between shifts, in the long, slow years of the voyage, will be unlike anything humans have ever had. A community of people who have all made the same sacrifice, who all understand the cost, who all share the strange burden of knowing that the world they left has aged past them. What kind of culture forms in that context? What kind of relationships? What kind of grief? And what kind of meaning? We do not know. We cannot know. We can only begin to imagine. And we must begin to imagine. Because if humanity is serious about reaching the stars, this is not a problem for future generations to solve. This is a problem that shapes the entire enterprise. The people who volunteer for these missions will need to understand, with complete clarity, what they are trading. Not just abstractly, not just mathematically, but emotionally, psychologically, spiritually. They will need to make peace with a loss that has no precedent, and they will need to maintain that peace across years or decades of travel. The selection criteria for interstellar crews will look nothing like the selection criteria for astronauts today. Today we look for physical fitness, technical competence, the ability to work in confined spaces with small teams. Those criteria will still matter, but they will be overshadowed by something far harder to measure: the capacity to carry irreversible loss without breaking, the ability to function, to stay sane, to maintain purpose in the face of a separation that can never be undone. Perhaps we will select for people who have already experienced profound loss. Perhaps we will look for individuals who have, through circumstance or choice, already demonstrated that they can rebuild meaning from rubble. Perhaps we will develop psychological training programs that simulate, as best we can, the experience of returning to a world that has moved on. Perhaps we will find that some people are constitutionally suited for this, and others are not, and that the difference has nothing to do with the qualities we currently value in explorers. Or perhaps we will discover that no amount of preparation is adequate, that the human mind, shaped by millions of years of evolution on a planet where time flowed at the same rate for everyone, simply cannot adapt to this, that the cost is not payable, not by anyone, not in any currency we understand. That would be its own kind of answer, a limit, a boundary that marks not the edge of what physics allows, but the edge of what psychology permits. Humanity might be able to build ships that approach the speed of light. We might be able to keep bodies alive for centuries. We might be able to navigate the void between stars with precision and grace. And yet the Enterprise might fail because the minds inside those bodies cannot survive the experience. This is not an argument against trying. This is an argument for honesty, for looking at the challenge with clear eyes before we romanticize it, for understanding that the people who go will pay a price that we, safe on Earth, will never fully comprehend. Let us turn, then, to the people who stay behind. Because the weight of time dilation falls on both sides of the departure. Imagine you are the parent of someone who leaves on an interstellar voyage. Your child is 35. They have trained for this mission their entire adult life. They believe, with the particular certainty of explorers, that this is what they were born to do. They have accepted the cost. They have made their peace. And now they are leaving, and you are standing on the observation deck watching the ship accelerate toward a point of light that you can barely see, knowing that you will never see your child again. Not that they will die. Worse than that. They will live. They will age. They will experience decades of existence. And you will experience decades too. But your decades will end, and they will still be young. You will die of old age while your child is still in their 40s. You will be buried on a planet your child cannot return to in time, and they will learn of your death, if they learn at all, through a message that takes years to arrive, that reaches them when you're not just dead but ancient history, a name in a database, a face in an archive. For parents, the calculus of time dilation is inverted. You do not age slower, you age faster. Every day you live on Earth is a day your child has not experienced. Every birthday you celebrate is a birthday they have not reached. And somewhere in that gap, you will cross a threshold. You will become older than your child will ever know you. They will remember you at 60. You will die at 80. And the 20 years between, your 70s, your decline, your final thoughts and wishes, will happen entirely without witness from the person you raised. This is a kind of grief that has no name. Not the grief of losing a child, which is devastating but understood. Not the grief of watching a child move away, which is painful but manageable. This is the grief of temporal separation, of watching time itself pull you apart, of knowing that the laws of physics, implacable and indifferent, have placed your child beyond your reach forever. And it is not just parents. It is siblings and friends and colleagues and neighbours. It is everyone who built a relationship with the traveller before they left. Each of them will experience the departure differently. Each of them will carry a different weight. But all of them will share the same fundamental reality. The person they knew has stepped outside their timeline. The person they loved is experiencing existence at a different rate. And the distance between them, measured not in miles but in moments, will only grow. How do societies process this? We have rituals for death, funerals and memorials and anniversaries. We have rituals for departure, farewell parties, and tearful goodbyes. But we do not have rituals for temporal separation. We do not have a framework for saying goodbye to someone who is still alive but experiencing time differently. We do not have language for the strange, ambiguous loss of knowing that your loved one exists but has fallen out of step with your existence. Perhaps we will develop such rituals. Perhaps the first interstellar departures will force humanity to invent new ceremonies, new language, new ways of marking the passage of people into different time streams. Perhaps there will be holidays, temporal memorials, where those left behind gather to remember the travellers, to imagine where they are in their journey, to calculate how much of their time has passed. Perhaps there will be letters, written not to be answered. The delay makes conversation impossible, but simply to be sent. Dispatches from Earth, describing what has changed, what has stayed the same, what the world looks like now. Messages that the traveller will receive years or decades after they were written, that will arrive as historical documents rather than correspondence, that will describe a world that has already changed again by the time the reader opens them. Perhaps there will be recordings, video messages from aging parents sent year after year, documenting the passage of time on Earth. A mother at 60, then 65, then 70, then 75. Each message a little more fragile, a little more aware that it might be the last. Each message carrying the weight of knowing that the recipient will watch them all at once, will compress a lifetime of aging into an afternoon of viewing, will see their parent grow old and die in what feels like a single day. These are the human costs that the equations do not capture. These are the weights that no amount of physics can quantify. Time dilation is real, but the numbers, the milliseconds, the years, the relativistic factors, tell only part of the story. The rest of the story is told in the faces of the people who stay behind, in the empty chairs at holiday tables, in the photographs that grow yellow and fade, in the names that are spoken less and less frequently as the decades pass and the memories thin. And yet there is something else here too, something that complicates the grief, that makes it different from ordinary loss. The travellers are still out there. They are still alive. They are still experiencing, still thinking, still existing, just elsewhere, just elsewhen. They have not ceased to be. They have simply ceased to be here, to be now. And that knowledge, strange as it is, might carry its own kind of comfort. When someone dies, they are gone, finished, the story has ended. But when someone travels at relativistic speeds, the story continues. It continues in a different place, at a different pace, but it continues. The traveller is still adding pages to their existence. They are still accumulating experiences, forming memories, living a life. And somewhere in the universe, perhaps orbiting a distant star, perhaps still crossing the void between, they are thinking of home. Perhaps that is enough. Perhaps that slender thread of continued existence, however tenuous, however separated by the geometry of space-time, is enough to transform the grief into something bearable. Not absence, not loss, but distance, temporary in the cosmic sense, even if permanent in the human one. This is the strange hope that time dilation offers alongside its costs. The knowledge that the universe is big enough and time is strange enough that the people we love can continue to exist even when we can no longer reach them. That existence itself is more durable than presence, that the story goes on even if we cannot witness its ending. The first interstellar travellers will test this hope. They will carry it with them, alongside their instruments and their provisions and their training. They will test whether the human heart can find comfort in separation, can find meaning in distance, can find peace in the knowledge that home continues to exist even when home can never be returned to. And those of us who stay behind will test it too. We will discover whether we can love someone across a time gap, whether we can maintain connection with a person experiencing reality at a different rate, whether we can find a new kind of relationship, neither presence nor absence but something in between, that acknowledges the strangeness of the situation without being destroyed by it. This is the psychological frontier, not just for the travellers, for all of us, and the exploration has already begun. In the milliseconds that accumulate on the International Space Station, in the tiny offsets that mark every returning astronaut as slightly, imperceptibly younger than they should be, in the quiet knowledge, shared by everyone who has ever orbited Earth, that they have stepped briefly outside the timeline they were born into. The costs are still invisible at this scale, the weights are still too small to feel. But the precedent has been established, the principle has been demonstrated, and the longer we push outward, the harder those costs will become to ignore. The clock is already ticking at different rates, the divergence has already begun, and somewhere in humanity's future, perhaps soon, perhaps not for centuries, we will face the full weight of what Einstein's equations demand. The weight arrives not all at once, but in increments, each increment corresponding to a choice, a mission, a destination farther from the sun. And the strange thing is, we will make those choices anyway. We will make them because the same restlessness that drove humans across oceans and over mountains and into the sky does not stop at the edge of the atmosphere. It does not stop at the moon. It does not stop at Mars. It keeps pushing, keeps reaching, keeps asking what lies beyond the next horizon, even when the cost of crossing that horizon is measured not just in fuel and distance, but in the very fabric of time itself. Consider what happens when the destination is not a space station 400 kilometers overhead, but a world around another star. Consider what happens when the journey is not measured in days or months, but in years, in decades, in subjective lifetimes separated from objective ones by factors that make the word contemporary meaningless. The nearest star system is Alpha Centauri, 3 stars locked in gravitational embrace, the closest of them, Proxima Centauri, sitting roughly 4.25 light-years from Earth. In cosmic terms, this is next door. In human terms, it is almost unimaginably far. Light itself, the fastest thing the universe permits, takes more than 4 years to cross that distance. And light travels at 300 million meters per second. A spacecraft capable of moving at even a fraction of that speed would represent a technological achievement beyond anything humanity has yet built. But let us assume, for the sake of following the thread to its end, that we build one. Let us assume that sometime in the coming centuries, human engineers solve the propulsion problem, the shielding problem, the life support problem, the 1,000 other problems that stand between us and the stars. Let us assume that a ship capable of carrying human beings to Proxima Centauri at, say, 90% of the speed of light is constructed, crewed, and launched. What happens then? The mathematics of time dilation provide a precise answer. At 90% of light speed, the Lorentz factor is approximately 2.29. This means that for every year that passes on Earth, only about 5 months pass aboard the ship. A journey of 4.25 light-years, at 90% of the speed of light, takes roughly 4.7 years as measured by earthbound clocks. But aboard the ship, the crew experiences only a little over 2 years of travel time. They age 2 years. Their families age nearly 5. Add the return journey. The crew turns around, accelerates back to 90% of light speed, and makes the trip home. Another 2 years of subjective time, another nearly 5 years of Earth time. By the time the ship touches down, the crew has aged roughly 4.5 years. Everyone they left behind has aged nearly a decade. A decade. Not milliseconds, not minutes. A decade of birthdays missed, of children growing up, of parents growing old, of friends drifting away, of the world changing in all the small and large ways that a decade allows. The travellers return to find that the baby they kissed goodbye is now in elementary school. The middle schooler is graduating. The grandparent who waved from the observation deck is buried in a cemetery that wasn't there when they left. And this is for the closest star. This is the minimum cost for the minimum interstellar journey. Push the destination farther out, and the divergence grows. Consider a star 20 light-years distant. At 90% of light speed, the round trip takes roughly 44 years of Earth time. The crew ages only about 19 years. They return to find that their contemporaries are now in their 60s or 70s, that the world has moved through nearly half a century of history, that the culture that launched them has evolved into something they might barely recognise. 2 decades of personal time have elapsed. Almost half a century of everyone else's time has vanished into the past. Consider a star 50 light-years away. At 90% of light speed, the round trip takes well over a century of Earth time. The crew ages approximately 48 years, a full lifetime of travel. But on Earth, more than 110 years have passed. Every single person they knew is dead. Not old, not retired, dead. The grandchildren of their grandchildren might be alive. The cities they remember have been rebuilt, abandoned, renamed. The languages they spoke may have drifted into new forms. They return as living fossils, walking artifacts from an age that exists only in archives and memory. And we have not yet approached the extreme end of the scale. We have not yet considered what happens at 99% of light speed, where the Lorentz factor climbs to approximately 7, or 99.9%, where it climbs to more than 22. At these velocities, the divergence becomes almost incomprehensible. A journey of 50 light-years at 99.9% of light speed takes only about 2.3 years of subjective time. The crew barely ages. They step off the ship youthful, vigorous, carrying memories of a world that ended generations ago. Their birth certificates are historical documents. Their family names might still exist, but the family lines have branched so many times that no living person remembers the original travellers as anything other than names in a database. This is what Einstein's equations demand. This is the price the universe extracts for the privilege of crossing stellar distances within a human lifetime. You can go. You can survive the journey, but you cannot return to your own time. You can never return to your own time. Let that settle for a moment. Let the weight of it find its proper place. The science fiction stories often present this as tragedy, and tragedy it is, in one sense. But there is another way to see it. A grimmer way, perhaps, but also a more honest one. The price is not hidden. It is not a trick. It is not a punishment. It is simply the structure of the universe made manifest. Time and space are woven together, and the weaving has costs. Anyone who chooses to travel at relativistic speeds knows the cost going in. They know that the journey purchases distance at the expense of simultaneity with the people they leave behind. And some will make that choice anyway. Some will decide that the exploration matters more than the return, that the knowledge matters more than the familiarity, that the stars matter more than the particular configuration of faces waiting on the particular planet where they happen to be born. This is not sociopathy. It is not coldness. It is a different kind of love. A love directed not at individuals but at the project of human expansion, at the survival of the species, at the idea that consciousness should not remain trapped on a single, fragile world forever. The first interstellar travellers will carry this love with them. They will carry it alongside the grief of separation, alongside the knowledge that they are choosing to become strangers to their own time. And perhaps that is enough to make the choice bearable. Perhaps the magnitude of the undertaking provides its own justification. When Scott Kelly returned from his year on the International Space Station, he came back to parades and interviews and book deals. When Sergei Krikalev accumulated his 800 days, he became a minor celebrity, the man who had lived longer in space than almost anyone. These tiny offsets, these milliseconds of time dilation, were treated as curiosities, as interesting footnotes to the real story of their missions. But the real story was hiding in those milliseconds. The real story was that the principle had been proven, that the mechanism had been demonstrated, that the clock of human separation from Earth time had begun to tick. Every subsequent mission would add more milliseconds. Every push farther from Earth would widen the gap, and eventually, inevitably, the milliseconds would become seconds, and the seconds would become minutes, and the minutes would become hours and days and years. The question is not whether this will happen. The physics is settled. The question is only how we will respond when it does. One response is despair. The recognition that the universe makes certain connections impossible, that the laws of physics place limits on love and presence and simultaneity that no technology can overcome. This is a legitimate response. It acknowledges the reality of the situation without flinching from its implications. It says, this is hard, this is painful, this is a genuine loss, and we should not pretend otherwise. Another response is acceptance, the recognition that the universe is strange and vast and operates according to rules that human intuition cannot fully grasp, and that our task is not to fight these rules, but to adapt to them, to find new ways of loving across time gaps, to find new definitions of presence that do not require simultaneity, to find peace in the knowledge that existence continues even when connection becomes impossible. A third response is transformation, the recognition that the challenges posed by time dilation might force humanity to change in fundamental ways, to develop new social structures that accommodate temporal separation, to develop new psychological frameworks that allow for relationships measured not in shared moments, but in parallel existences, to develop new technologies, perhaps involving communication, perhaps involving consciousness itself, that bridge gaps that cannot be bridged physically. Which response will prevail? We do not know. We cannot know. The answer depends on choices not yet made, technologies not yet invented, journeys not yet undertaken. But the question is already being asked, in laboratories and mission control centres, in the minds of every astronaut who watches Earth's curvature recede through a spacecraft window and thinks about what it means to be moving through time at a different rate than everyone they love. The training programs do not include this. There is no NASA course on the psychological implications of time dilation, no module on how to maintain relationships across relativistic gaps. The offsets are still too small to matter practically. Scott Kelly's 5 milliseconds did not require therapeutic intervention. Sergei Krikolev's 20 milliseconds did not strain his marriage in any measurable way. But the precedent matters. The principle matters. The knowledge that the gap exists, that it is real, that it's growing with every kilometre of altitude and every increment of velocity. This knowledge matters. It plants a seed. It begins a conversation that humanity will eventually need to have in earnest. How do you say goodbye to someone who will not age at the same rate as you? How do you maintain connection with a person whose now is drifting away from yours? How do you prepare a child for the possibility that a parent might return from a journey younger than the child themselves? These are not hypothetical questions. They are questions that will need answers within the lifetimes of people alive today. The first crewed missions to Mars will push the offset into measurable territory. The first interstellar probes, even uncrewed ones, will push our thinking into territory we have never occupied before. And eventually, perhaps within this century, perhaps within the next, the first human beings will depart for another star system, knowing that they are leaving their timeline behind. The preparations for that departure will be unlike any preparations humanity has ever made. Not just the engineering, not just the biology, the psychology, the sociology, the philosophy. We will need new frameworks for understanding what it means to belong to a family, a community, a species, when the fundamental assumption of shared time no longer holds. Consider a society that has sent multiple interstellar missions. Consider a future Earth that has, scattered across the light years, dozens of ships carrying human beings toward distant stars. Some departed recently, still close enough that communication delays are measured in years rather than decades. Others departed generations ago and are now so far away that the lag in communication makes dialogue impossible. Messages sent from Earth would arrive to find the recipients dead of old age, their children dead of old age, their grandchildren perhaps just receiving words addressed to ancestors they never knew. How does such a society think of itself? How does it maintain coherence when portions of its population exist in what amount to different temporal universes? How does it make decisions that affect all of humanity when all of humanity can no longer be present at the same moment to participate in those decisions? These are governance questions disguised as physics questions. They are questions about identity, about continuity, about what it means to be a civilization when civilization has fragmented across space-time in ways that make reunification impossible. The analogy to early human migration is tempting, but ultimately breaks down. When humans walked out of Africa, when they crossed the Bering Land Bridge, when they sailed to distant islands, the separations were geographic and potentially reversible. A community that settled in Australia might be cut off from a community in Europe for tens of thousands of years, but the disconnection was always, in principle, bridgeable. The descendants could eventually meet. The timelines remained synchronized. But when humans travel at relativistic speeds, the separations become temporal and fundamentally irreversible. The descendants cannot meet their ancestors, not in any meaningful sense. The timelines diverge permanently. The now that the travellers left becomes the past of everyone who stayed, and no amount of travel can restore the alignment. This is the phase transition. This is the moment when exploration becomes something genuinely new, when the costs escalate from inconvenience to irreversibility. And we are approaching it. We have not reached it yet. Our fastest spacecraft still crawl through the solar system at velocities that make relativistic effects negligible. But we are moving toward it, and the approach itself changes how we should think about space exploration. Every step we take outward is a step toward this threshold. Every increase in velocity brings it closer. Every mission that pushes the boundaries of distance and duration is a rehearsal for the real thing, for the moment when a crew boards a ship knowing they will never share a present moment with Earth again. The question is not whether humanity will reach that threshold. The question is only when. The drive to explore is too strong. The stars are too compelling. The restlessness that pushed humans across every terrestrial frontier will eventually push us across this one too. And when it does, we will face the full weight of what time dilation demands. Centuries will pass on Earth while years pass on ships. Children will be born, grow old, and die while their relatives drift through the interstellar medium, aging slowly, experiencing a reality stretched thin across distances that make communication impossible. The human family will fragment not just across space but across time, and the fragmentation will be permanent. This is the price of the stars. This is what Einstein's equations demand in exchange for letting us cross the light years. It is neither fair nor unfair. The universe does not deal in fairness. It simply is. And our choice is only whether to pay it or to remain forever on this single world, this single timeline, this single now that grows smaller every year as our ambitions grow larger. For now, the price remains invisible. The milliseconds that accumulate on the International Space Station are too small to feel. The tiny age difference between Scott Kelly and his brother is a curiosity, a conversation piece, a footnote to an otherwise triumphant story of human achievement. But the footnote is growing. With every mission, it grows a little larger. With every push outward, it becomes a little harder to ignore. And somewhere in humanity's future, perhaps soon, perhaps not for generations, a crew will board a ship knowing that the footnote has become the main text, that the price is no longer invisible, that the divergence is no longer measured in milliseconds, but in years, in decades, in lifetimes. They will say their goodbyes. They will hold the people they love for the last simultaneous moment they will ever share. They will walk up a ramp or float through a hatch, and they will seal themselves into a vessel designed to carry them across distances that make the word home meaningless. And then they will accelerate. The world they leave behind will continue to exist. The people they love will continue to exist. But the connection, the synchrony, the shared present, these will end. Not with death, not with disaster, simply with physics, simply with the geometry of space-time asserting itself, drawing a line between what was shared and what will never be shared again. The light from Earth will still reach them. Messages will still arrive, delayed by the growing distance, carrying news from a world that is aging faster than they are. They will learn of births and deaths, of wars and peace treaties, of technologies invented and cultures transformed. They will learn of changes they cannot participate in, decisions they cannot influence, moments they cannot share. and the messages they send back will arrive too late. Always too late. The people they address will have moved on, aged, died, been replaced by generations who know the travellers only as names, as stories, as ancestors who departed before living memory. This is the loneliness that waits at the edge of interstellar space. Not the loneliness of empty distance, though there will be plenty of that. Not the loneliness of isolation from human contact, though that too will be real, but the loneliness of temporal separation, the loneliness of existing in a present that no one else occupies, the loneliness of knowing that the universe has drawn a boundary around your existence, and that boundary cannot be crossed by any technology, any effort, any love, and yet they will go. They will go because the stars are there, because the questions are there, because the possibility of finding other life, other minds, other civilizations is too important to abandon. Because humanity's survival may depend on spreading beyond this single vulnerable world. Because the drive to explore is older than civilization, older than agriculture, older than language itself. They will go carrying the full weight of what the journey costs, and those of us who stay behind will carry a different kind of weight, the weight of watching them leave, knowing we will never see them again, knowing that by the time they return, if they return at all, we will be dust and memory. The milliseconds that separate Scott Kelly from his brother are the first grains of sand in an hourglass. The hourglass has barely begun to empty, but it has begun, and here is where the mathematics begins to feel less like physics and more like philosophy. Because time dilation does not merely separate travellers from their homeworld, it separates them from each other. It separates them from themselves. It raises questions that Einstein's equations can answer precisely, but that human intuition struggles to absorb. Consider the ship itself, a vessel carrying a crew of 20 toward a distant star system. They accelerate together, coast together, decelerate together. Their clocks stay synchronized throughout the voyage. To each other, they remain contemporaries, companions, people who share the same present moment even as that moment diverges further and further from Earth's timeline. The social bonds hold, the conversations continue, the friendships deepen or fray in the normal human way. Inside the ship, time flows as time has always flowed, one second following another in perfect regularity. But now imagine the mission carries them to multiple destinations. A first stop at Proxima Centauri, a second at Tau Ceti, a third at Epsilon Eridani, each leg of the journey requiring fresh acceleration to near-light speeds, each arrival and departure adding new layers of temporal displacement. The crew that finally returns to Earth will have accumulated perhaps 50 years of relativistic offset. 50 years that Earth experienced and they did not. 50 years of history compressed into a journey that felt to them like perhaps a decade. Now imagine something more complicated. Imagine the mission requires the crew to split. Half continue to a further destination while half return home early, carrying data and samples back to Earth. The two groups accelerate in different directions at different speeds for different durations. Their clocks diverge not only from Earth's but from each other's. When they meet again, if they meet again, they will have aged differently. Crewmates who were the same age at departure might now be separated by years or decades of biological time. A navigator who left as a contemporary of the ship's doctor might return to find that doctor elderly, or might find that the doctor is now younger than she is, depending on whose trajectory accumulated more temporal offset. The mathematics allows all of this. It allows situations where the question of who is older becomes dependent on which frame of reference you choose to measure from. It allows situations where two people can each correctly claim that the other has aged more than they have, not because either is wrong, but because there is no universal now against which to compare them. It allows situations where the very concept of simultaneous events breaks down entirely. This is the relativity of simultaneity, and it is perhaps the strangest consequence of Einstein's work. Two events that appear simultaneous to one observer may appear sequential to another observer moving at a different velocity. A birth on Earth and a birth on a starship that seem to happen at the same moment from Earth's perspective may have happened years apart from the starship's perspective. The question of whether they happened at the same time has no universal answer. It depends on who is asking and how they are moving when they ask. Let that settle for a moment. Not just time dilation, which tells us that clocks run at different rates depending on velocity and gravity. but the relativity of simultaneity, which tells us that the very idea of right now only exists locally. There is no cosmic clock ticking off a universal present moment. There is no objective answer to the question, what is happening on Earth right now from the perspective of a distant starship? The question itself is malformed. Right now is not a feature of the universe. It is a feature of your particular location, your particular velocity, your particular trajectory through space-time. The philosopher of physics Craig Callender has written extensively about this, about how deeply counterintuitive it is for human beings who evolved on a single planet, surrounded by clocks that all agreed with each other, to suddenly discover that simultaneity itself is relative. Our entire social existence depends on shared present moments. We make appointments, we coordinate schedules, we say I'll meet you at noon, and expect that noon will mean the same thing for both of us. We experience consciousness as a sequence of now moments flowing one after another, and we assume, without ever questioning it, that everyone else is experiencing the same sequence, that the now I inhabit is the same now my family inhabits, that when I think of someone far away, they exist in the same present moment I do. They do not. Not precisely. Even on Earth, with clocks separated by nothing more than altitude or latitude, the differences exist. A clock at sea level runs slightly slower than a clock on a mountaintop, because gravity is stronger at sea level. A clock at the equator runs slightly slower than a clock at the poles because the equator is moving faster through space as Earth rotates. These differences are measured in nanoseconds, in picoseconds, in quantities too small for any human sense to detect. But they are real, they accumulate, and they mean that even here, on this single world, the shared present we take for granted is an approximation. A very good approximation, but an approximation nonetheless. The GPS satellites in orbit understand this with perfect clarity. Their atomic clocks are programmed to disagree with ground-based clocks by precisely the amount that relativity predicts. Because if they did not, the navigation system would fail within hours. Your phone can tell you where you are within a few meters because engineers built Einstein's corrections into the software. Every time you ask for directions, you're relying on relativity being exactly true. Every successful GPS fix is another confirmation that time does not flow uniformly, that clocks are not universal, that the shared present is an illusion maintained by the coincidence of slow speeds and weak gravity. Interstellar travel shatters that illusion. It takes the tiny disagreements that accumulate over nanoseconds and amplifies them into years. It takes the philosophical oddity of relative simultaneity and turns it into a lived human experience. A traveller bound for a distant star will experience this not as an abstract concept, but as a concrete fact of their existence. Their present will cease to be anyone else's present. Their now will drift away from Earth's now like a boat untethered from a dock, carried by currents no one can resist. And here is where the loneliness deepens into something almost metaphysical. Because the traveller cannot even accurately imagine what is happening on Earth. They can calculate what has likely happened, based on the time lag and the known physics. They can receive messages that tell them what did happen, months or years ago, by their own clock. But they cannot know what is happening right now on Earth because there is no right now on Earth that corresponds to their right now. The question is meaningless. The universe refuses to answer it. Picture a traveller halfway to a star 20 light-years distant. They have been accelerating for what feels like 3 years. They have covered perhaps 8 light-years. Messages from Earth take 8 years to reach them, carrying news of events that happened 8 years before the message arrives, which is to say events that happened 11 years ago by the traveller's own reckoning. Messages they send back will take 8 years to arrive on Earth, carrying news that will be old before it reaches anyone. The conversation is possible but fractured, stretched across timescales that make real dialogue impossible, and yet the traveller cannot help but imagine Earth as it exists now, cannot help but picture their family, their home, the cities and landscapes they left behind, cannot help but wonder what is happening there at this very moment. The human mind is not built for relativity. It is built for the African savannah, where the speed of light might as well be infinite and where simultaneity is as obvious as the sun in the sky. Every instinct the traveller has tells them that Earth exists right now, that their family is doing something right now, that the world they left is continuing in parallel with their journey. But physics says otherwise. Physics says that right now is a line the traveller draws through space-time, and depending on how they're moving, that line slices through Earth's timeline at a different angle. A traveller coasting at half the speed of light draws that line at a significant tilt. What they call now on Earth might be years ahead of or behind what an observer on Earth would call now. The tilt changes as the traveller accelerates or decelerates. The present moment on Earth shifts, from the traveller's perspective, like a spotlight sweeping across decades of history. This is not time travel in the science fiction sense. The traveller cannot visit the past or alter events that have already happened. But it is something almost as strange. A complete decoupling of temporal reference frames, a situation where the question, what is happening at home, becomes not just unanswerable but undefined. The physicist and philosopher Hans Reichenbach called this the conventionality of simultaneity, arguing that even the definition of same time requires arbitrary choices about how to synchronize distant clocks. Different choices lead to different answers, and no choice is more correct than any other. The universe does not prefer one definition over another. It simply refuses to have a universal present moment, and leaves us to construct our own local versions as best we can. For interstellar travellers, this means constructing a now that no one else shares, a private present moment, sealed inside the hull of a ship connected to all other present moments only by light signals that carry the past and by calculations that predict a future that will have already become the past by the time any confirmation arrives. This is isolation of a kind humanity has never experienced. Every lonely explorer in history, every castaway on a desert island, every prisoner in solitary confinement, at least shared a present with the world that had abandoned them. They could look up at the same stars their families saw, knowing that when they looked, their families might be looking too. They could experience a sunset and know that somewhere the same sun was setting for the people they loved. The present connected them even when distance and circumstance kept them apart. The interstellar traveller does not have this. The stars they see are not the same stars their families see. Or rather, they are the same stars, but seen from a different moment in time, filtered through a different slice of space-time, part of a different now that has no overlap with anyone else's. The isolation is not just spatial but temporal, not just a matter of distance but a matter of existence itself, unfolding in a frame of reference that the universe does not share with anyone. And yet there is something almost beautiful in this loneliness, something that philosophy has struggled to articulate, but that science reveals with crystalline precision, because the same physics that isolates the traveller also connects them to the deepest structure of reality. The same equations that break the shared present also reveal that space-time is a single unified entity, that past and future are not separate categories, but different directions in a four-dimensional landscape, that the universe contains all moments, all events, all configurations of matter and energy, existing together in a way that transcends the human experience of time flowing from one moment to the next. This is the block universe interpretation of relativity, and while philosophers debate its implications, the mathematics is undeniable. In relativity, there is no fundamental distinction between past, present, and future. All three are equally real, equally part of the space-time continuum. The experience of the present as special, as the only moment that truly exists, is a feature of consciousness, not a feature of physics. From the perspective of the equations, a moment in the past is just as real as this moment, and a moment in the future is just as real as either. They are all there, all part of the same unchanging four-dimensional structure, differing only in where you happen to be looking. If this interpretation is correct, and many physicists believe it is, then the traveller's isolation is in some sense an illusion. Their family on Earth continues to exist, not in a present moment that the traveller cannot share, but in a different region of space-time, as real and as permanent as the traveller's own region. The separation is real, the inability to communicate in real time is real, the divergence of clocks is real, but the existence of the people left behind is also real, even if the traveller can never reach them again, even if the universe has drawn a line between their moments that no signal can cross. This may or may not be comforting. Philosophy can offer the traveller a way of thinking about their situation that removes the sting of temporal isolation. But philosophy cannot change the lived experience of loneliness, the ache of missing people you can never see again, the strange grief of knowing that the world you left is still there but unreachable, that the people you love are still living but in a different now that will never again coincide with yours. And there is another wrinkle, one that the physics makes unavoidable but that human intuition struggles to accept. The traveller will age, the people left behind will age, and when messages finally arrive carrying news across the light years, they will carry evidence of that aging. The traveller will watch their family grow old in compressed time, receiving updates that show children becoming adults, adults becoming elderly, the elderly becoming memories. The traveller will send back their own updates, their own images, their own evidence of aging. But because they have experienced less time, they will appear to age more slowly. Their family will watch them remain young, or at least younger, while they themselves grow old. Imagine receiving a video message from your child sent when your child was 35, arriving when you have been away for what feels like 10 years. In the message, your child is showing you their grandchildren, your great-grandchildren, children you never knew existed, children named after you, children being told stories about the traveller who went to the stars. Your child is grey-haired, lined, speaking of retirement and memory, and the strange comfort of knowing that somewhere out there, their parent is still alive, still young, still journeying toward a destination that the child will never see. And you will record your reply, knowing that by the time it arrives, your child may be dead. Knowing that your great-grandchildren may be the ones to receive it. Maybe watching a message from a great-grandparent who looks younger than their parents, who speaks of events decades out of date, who exists in a version of reality so remote from their own that it might as well be fiction. You will speak into a camera, sending your words across a gulf that no technology can bridge in real time, knowing that the gap between transmission and reception will swallow generations. This is the tragedy that relativity writes into every interstellar mission profile. Not the risk of mechanical failure, not the danger of radiation or micrometeorites, or the 1,000 technical challenges of surviving in deep space, but the simple, inexorable mathematics of time itself, treating travellers and those they leave behind as members of different temporal civilizations, separated not by distance alone but by the geometry of existence. And the missions will fly anyway. Humanity will not be deterred by tragedy. We never have been. Every dangerous voyage in history launched with full knowledge of the risks, with full knowledge of the likelihood that many would not return, with full knowledge that the price of exploration is always paid in human lives and human suffering. The interstellar missions will be no different. The mathematics will be explained to the crews, the implications will be understood, and people will volunteer anyway, knowing that the divergence begins the moment the engines ignite, knowing that every second of acceleration carries them further from a shared present with everyone they have ever known. They will volunteer because some prices are worth paying, because some discoveries justify any cost, because the alternative, remaining forever on a single world, never knowing what lies beyond, never answering the questions that have haunted humanity since the first ancestor looked up at the stars, is a price of its own. A different kind of tragedy. A tragedy of missed possibilities, of journeys never taken, of a species that stayed home out of fear of what the journey would demand. The universe offers no easy choices. Relativity is not a negotiating partner. The equations do not care about human hopes or human suffering. They simply describe the rules by which space-time operates, and those rules include the isolation that waits at the edge of light speed, the temporal loneliness that no technology can cure. And so the first interstellar travellers will carry this knowledge with them like ballast. It will weight their decisions, it will shade their farewells, it will complicate their relationships with each other, knowing that even among the crew, temporal divergence may eventually separate them if their trajectories diverge. But it will not stop them. Nothing has ever stopped humanity from reaching for the next horizon, and nothing will stop us from reaching for this one, even when the next horizon exists in a different now, a different temporal neighbourhood, a region of space-time that cannot be visited and then departed, only visited and then mourned. The ship accelerates, the clocks begin to diverge, and somewhere in the mathematics, a new form of human experience comes into being, the experience of existing in a present moment shared with no one, isolated by the structure of reality itself, connected to the rest of humanity only by signals from the past and hopes for the future. This is the territory we're entering, not today, perhaps not for generations. But the trajectory is clear, and the physics is patient. It has been waiting for us since the universe began, written into the fabric of space-time, ready to exact its price whenever we finally gather the courage to pay it. The milliseconds that separate Scott Kelly from his brother were the announcement, the quiet statement that the rules apply. That time is not what we thought it was. That the shared present we have always taken for granted is a local phenomenon, a provincial assumption, a comforting illusion that the universe maintains only for creatures who move slowly and stay close to home. We are beginning to move faster, we are beginning to reach further, and the illusion is beginning to fray. Not yet in ways that matter to most people, not yet in ways that change lives or break families or force anyone to make impossible choices, but the fraying has begun. The first threads have separated, and somewhere ahead, in a future that may be closer than we imagine, the fabric will tear entirely, and humanity will have to learn to live with a new kind of solitude, the solitude of temporal separation, of clocks that no longer agree, of present moments that drift apart like ships in a vast dark sea. The sea has always been humanity's teacher in matters of departure. Sailors understood something that landlocked civilizations often forgot, that when you cast off from shore, you do not simply leave a place. You leave a version of that place frozen in time at the moment of your departure. The port you return to will have the same name, the same coordinates, the same familiar landmarks, but the people will have aged, the buildings will have changed, the conversations will have moved on without you. Every voyage was a small death and a small resurrection. You buried one version of home when you left and met a stranger wearing its face when you returned. The interstellar voyagers will understand this lesson more deeply than any sailor ever could. They will understand it not as metaphor but as physics. The home they leave will not merely change in their absence. It will exist in a fundamentally different temporal moment, a different slice of space-time, a different when that cannot be visited again no matter how precisely they retrace their route through space. The coordinates might match. The planet might still spin on its axis, still orbit its star, still carry the descendants of everyone the travellers once knew. But the moment will be gone. The shared present will have closed behind them like water closing behind a hull, and all the precision navigation in the universe cannot sail backward through time. This is not tragedy in the classical sense. Tragedy implies a flaw, a mistake, a wrong turn that might have been avoided with better judgment or greater wisdom. The temporal isolation of interstellar travel is not a flaw in the plan. It is the plan. It is the price written into the equations, and the equations cannot be rewritten. They are not human laws that might be amended or repealed. They are the operating code of reality itself, and they specify quite clearly that velocity costs time, that distance costs simultaneity, that the faster and further you go, the more thoroughly you become separated from the moment you departed. Some future philosopher, perhaps aboard one of those first-generation ships, will find words for this that we cannot yet imagine. They will develop concepts and frameworks for thinking about temporal separation that make our current vocabulary seem as primitive as stone tools. They will understand loneliness in dimensions we cannot perceive, and they will find meaning in that loneliness that we cannot anticipate. But they will not solve it. They will not cure it. They will simply learn to live with it, the way humanity has learned to live with every other limitation that the universe imposes, with mortality, with entropy, with the vast distances between stars that make travel possible but communication agonizing. They will add temporal isolation to the list of prices that conscious beings pay for existing in a universe built on these particular rules, and they will pay it, and they will keep going anyway. Because that is what we do. That is what we have always done. We encounter limits, we measure them, we understand them, and then we decide whether to accept them as permanent boundaries or as challenges to be met with whatever resources we can muster. We decided long ago that distance was not a permanent boundary. We built ships and crossed oceans. We built airplanes and crossed skies. We built rockets and crossed the void between Earth and its moon. Each crossing demanded sacrifices. Each crossing imposed costs. And each crossing was undertaken anyway, because the alternative, staying behind, staying safe, staying exactly where we were, was a cost of its own that someone decided was too high to pay. The interstellar crossing will be different in degree but not in kind. The sacrifices will be larger. The costs will be measured in years rather than days, in permanent separation rather than temporary absence, in farewells that cannot be followed by reunions. But the essential human calculus will remain the same. Someone will look at the equations, someone will understand what they mean, and someone will decide that the knowing is worth the price of the going. Picture that moment. Not the launch, not the acceleration, not the technological triumph of achieving a meaningful fraction of the speed of light. Picture the moment before, picture the crew in whatever waiting room the future provides, facing whatever version of family and friends that future allows them to bring together. Picture the quality of silence in that space, the weight of words unsaid because no words could possibly be adequate, the strange mixture of pride and grief that must characterize any gathering where someone is being celebrated for undertaking a journey that will remove them from the shared human present. What do you say to someone who is about to become unreachable in time? What farewell covers not just the distance they will travel, but the years that will accumulate differently for them than for you? What goodbye acknowledges that by the time they return, if they return, you will be dust and memory, your great-grandchildren older than you are now, your world transformed into something that would be unrecognizable to either of you? We have no scripts for this, no cultural templates, no inherited rituals, no traditional words passed down through generations. Every human farewell in history has assumed a shared timeline, a common clock, a future in which both parties might potentially meet again if circumstances allowed. Even our farewells to the dying assume a kind of temporal solidarity. They are leaving the timeline entirely, not simply drifting into a different version of it. The interstellar farewell will require new ceremonies, new words, new ways of honouring both the courage of the departure and the permanence of the separation. Perhaps those ceremonies will draw on ancient sources. Perhaps they will find inspiration in the rituals that surrounded sailors departing for unknown waters, settlers leaving for new continents, explorers venturing into territories from which return was uncertain at best. Perhaps they will draw on the rituals of death itself, acknowledging that what is being mourned is not a life but a presence, not a person but a shared moment. The travellers will still exist. They will still live their lives, pursue their purposes, experience their joys and sorrows. But they will do so in a different present, a present that belongs to them alone, a present that cannot be visited or shared, no matter how much love stretches across the years. And perhaps that is the deepest lesson that relativity teaches us about time. Not that it passes at different rates for different observers. That is merely the mechanism, the technical specification, the operating instruction. The deeper lesson is that the present moment, the now that we share with everyone around us, the simultaneity that makes communication and community and love possible in their most immediate forms, this present is not guaranteed. It is not universal. It is not a fundamental feature of existence that all conscious beings automatically share simply by virtue of being alive at the same time. The present is local. It is fragile. It is a gift that the universe gives to creatures who move slowly and stay close together. And it is a gift that the universe quietly withdraws from creatures who dare to move fast and travel far. We have always known this in some vague, intuitive sense, that distance strains relationships, that time apart changes people, that the friend who moved away and the friend who stayed nearby inhabit slightly different worlds, even if their clocks agree to the millisecond. But we have never had to confront it as physics. We have never had to accept that the separation is not merely emotional or practical, but ontological, written into the structure of reality at its deepest level. The interstellar age will force that confrontation. It will demand that humanity develop a new understanding of connection itself, what it means to be connected to someone when you cannot share a present moment with them, what it means to love someone whose now is years or decades offset from your own, what it means to belong to a civilization whose members exist in a temporal archipelago rather than a single continuous present. This is not a future that any of us will see. Not in its full development, not in its mature form. The first tentative steps, the years aboard space stations, the months on Mars, the eventual crewed missions to the outer solar system, these will barely scratch the surface of what is coming. The divergences will remain small enough to ignore, small enough to joke about, small enough to fold into the existing categories of human experience without breaking them. We will notice that astronauts age slightly less than their earthbound counterparts, and we will marvel at the precision of our measurements, and we will continue assuming that we all inhabit the same present, because for practical purposes, we still do. But the trajectory is set. The knowledge is accumulating. The engines are being designed, the propulsion systems theorized, the relativistic effects calculated with ever greater precision. And somewhere in those calculations, written in the cold language of mathematics, is a future that our descendants will have to navigate. A future where the present fragments, where simultaneity becomes a local phenomenon, where the human family spreads not just across space but across time itself, each branch drifting into its own temporal neighbourhood, connected by light-speed messages from the past but never again by the simple gift of sharing the same now. Let that settle. Let the weight of it press down. Not as tragedy, not as horror, not as a reason to turn back from the stars, simply as truth, simply as the shape of reality that physics has revealed and that humanity will eventually have to inhabit. The universe did not design itself for human comfort. It did not arrange its laws to make interstellar travel easy or painless or compatible with our emotional needs. It simply exists, operating according to rules that long predate any conscious observer, rules that will long outlast any civilization that rises to understand them. Those rules include the isolation that waits at high velocity. They include the temporal loneliness that no amount of engineering can engineer away. They are not punishments or obstacles placed in our path by a hostile cosmos. They are simply the rules, the operating parameters, the specifications by which space-time functions. And within those specifications, within those constraints, within those rules that cannot be negotiated or appealed, humanity will build its interstellar future anyway. Because that is what conscious beings do when faced with a universe that offers no easy paths. They take the hard paths, and they find meaning in the taking, and they discover that meaning can exist even in isolation, even in loneliness, even in the slow accumulation of years that separates travellers from everyone they leave behind. Think about the signals, the light-speed messages that will carry back and forth between Earth and the departing ships, between the settled worlds and the vessels still in transit, between all the scattered outposts of a spacefaring humanity. Each message will carry information from the past, information about events that have already happened, people who have already aged, decisions that have already been made. No message will ever carry information about the present, because by the time any message arrives, the present it describes will be gone, replaced by a newer present that is already becoming past. This is true even now, of course. When you talk to someone across a room, the light carrying their words takes a fraction of a nanosecond to reach you, and in that fraction, they have already moved on to a slightly newer present. But the delay is so tiny, so utterly beneath the threshold of human perception, that it does not matter. We can safely treat room-scale conversations as simultaneous, as shared, as taking place in a common present that both parties inhabit together. Interstellar communication will not offer that illusion. When a message from Earth reaches a ship travelling at 90% of the speed of light, that message will be years old at minimum. The sender may have aged decades in the time the signal was in transit. The news it carries, however urgent it seemed when transmitted, will describe a world that no longer exists in that form, events that have long since unfolded into consequences that the recipient cannot yet know. And when the recipient replies, the same delay will apply in reverse. The reply will reach an Earth that has moved on, addressed to recipients who may be old or dead, or simply unrecognizable as the people they were when the original message was sent. This is communication across time as much as across space. It is correspondence with the past, maintained by beings who cannot share a present. And yet it will be precious. Precious beyond measure. Because it will be the only thread connecting the scattered branches of humanity, the only proof that somewhere out there, across the years and light years, someone is thinking of you, remembering you, wondering about you, sending their hopes and words across the void in the faith that someone will receive them, even if that someone exists in a different temporal moment. The first interstellar families will develop new customs around these messages. They will compose them differently, knowing that the recipient will be older when they arrive. They will think in longer arcs, speak in terms of decades rather than days, plan for a future that both parties will experience but never share. They will learn to love across time in ways that no previous generation has had to love, not through the shared small moments that make ordinary love possible, but through the patient accumulation of signals, the slow exchange of updates, the gradual recognition that the person you love is growing and changing in a temporal current you cannot enter. It will be a strange form of love, perhaps a deeper form, perhaps the form that love takes when it is stripped of convenience and proximity, and the comfortable assumption that you can simply reach out and touch the person you love whenever you want. The interstellar lovers will have none of that. They will have only their memories of shared moments from before the divergence, and their messages from the past, and their hopes for a future that may never bring them back into the same present. And it will be enough. It will have to be enough. Because the alternative, refusing to love anyone who travels, refusing to let anyone you love leave, staying always within the narrow temporal neighbourhood that allows shared presence, that alternative would be its own kind of prison. A prison built of love that has become too afraid to stretch, too small to accommodate the vastness that humanity is reaching toward. The interstellar age will demand a larger love, a love capable of surviving temporal separation, a love that understands that presence is not the only form of connection, that shared moments are not the only basis for devotion, that you can hold someone in your heart across years of divergence as surely as you can hold them across a room. Perhaps this is what the universe is teaching us. Perhaps this is the lesson written into the equations of special relativity, the lesson that Einstein encoded without knowing it, the lesson that every interstellar traveller will have to learn in order to survive the journey psychologically, the lesson that love is not limited by the constraints that physics places on presence, that care and connection and devotion can stretch across time as well as space, that the price of exploration is always paid in separation, but the separation does not have to mean the end of what connects us. The milliseconds that separate Scott Kelly from his brother are not tragedy. They are not loss. They are the first faint hint of a vast expansion in what human relationships can become. Relationships that span not just distance but temporal intervals. Relationships maintained by patience and faith, and the slow exchange of light-speed messages. Relationships that grow and deepen even when the people involved cannot share a present moment. This is the future that physics has prepared for us. Not the future we might have chosen if we were designing a universe ourselves. Not the convenient, comfortable future where travel has no cost and presence is always possible. But a richer future in some ways. A future where love is tested and proved and discovered to be stronger than we imagined. A future where connection stretches to accommodate new forms of separation. A future where humanity learns that we are capable of more than we thought. Capable of maintaining bonds across years of divergence. Capable of finding meaning in journeys that cannot be reversed, capable of building a civilization that spans not just space, but the fragmented temporal archipelago that spacefaring creates. The first interstellar travellers are not born yet. The ships that will carry them have not been designed. The propulsion system that will push them toward the necessary fraction of light speed exists only as equations and dreams. But the physics is waiting. It has been waiting since the universe began, patient and certain, describing the rules by which any intelligence that dares to travel fast will have to play. And when we finally muster the courage to accept those rules, when we finally decide that the knowing is worth the cost, when we finally send our children towards stars that we ourselves will never see, we will discover that the equations were not only obstacles, they were also invitations. Invitations to become something larger than we have been. Invitations to stretch our understanding of connection and presence and love to accommodate the vastness that awaits us. Invitations to learn, finally and permanently, that time is not the rigid backdrop we always assumed, but a flowing, flexible, treacherous medium that will shape our species' future in ways we can barely begin to imagine. You can return to Earth. You can never quite return to the Earth you left. But somewhere in that truth, hidden inside that apparent loss, is a promise. The promise that out there, across the light years and the years, something is waiting to be known. Something is calling to be discovered. Something justifies the price that physics demands, and we will go, not today, not tomorrow. But eventually, inevitably, we will gather our courage and pay the price and step into the stream of time that will carry us away from everything familiar. Because that is what we are. That is what consciousness does when it looks up at the stars and realizes that they are reachable. The clocks will diverge, the present will fragment, and humanity will scatter across time as well as space, learning new forms of connection, discovering new depths of love, becoming something vaster and stranger, and more beautiful than we can currently conceive. The milliseconds are the announcement. The stars are the invitation. And somewhere out there, in a future measured by decades and light years, our descendants will send a message back. A message that will arrive long after they sent it, carrying news from a present we can never share, addressed to people who existed in a moment that has long since closed. That message will cross the void, it will arrive, and someone will read it, and know that out there, impossibly far away in space and time, someone is thinking of them. Someone remembers. Someone is still reaching back across the years, the way we have always reached toward each other, the way we always will, no matter how far the journey, no matter how wide the divergence, no matter how strange the mathematics of time becomes. This is what we carry with us into the interstellar age. Not certainty, not safety, not the comfortable illusion of a shared present that stretches unbroken across all of space-time. Only this, only love, stretching further than we ever imagined it could stretch. Only hope, reaching across temporal chasms that would have seemed unbridgeable. Only the human refusal to stop reaching, stop connecting, stop caring about people we may never again share a present moment with. The universe built these rules into its foundation. Time flows differently for travellers than for those who stay home. The mathematics is exact. The isolation is real. But it did not account for us. It did not account for creatures who would look at those equations, understand what they meant, and decide to love across the divergence anyway. The stars are very far away. The price of reaching them is measured in years that cannot be recovered, presents that cannot be shared, farewells that cannot be followed by the kind of reunions we have always assumed were possible. And we will reach for them anyway, because that is who we are, because some journeys are worth any price, because the universe, in all its vast indifference, did not expect creatures who would choose connection over convenience, discovery over safety, the hard path over the easy one. It did not expect us, and we are only just beginning.